At 2 a.m., a safe migration brought down your API for 45 minutes. Database CPU hit 100%, all queries timed out, because Prisma's auto-generated SQL rewrote the entire table. Let's break down Prisma ORM with Node.js, modern database access, how it works, and the exact mistake behind that failure. Prisma is a schema-driven ORM. You define your data model in a schema file, and Prisma generates a fully typed client. It handles migrations, queries, and even provides a GUI for data inspection. Traditional ORMs have complex configs and type safety gaps. Prisma's schema-first approach generates both migrations and the client, ensuring your code and database stay in sync. Start by installing the Prisma CLI and client. Then run Prisma init to create your schema file and generate the client. This installs Prisma and initializes the project with a schema file. The Prisma schema is the heart of your database configuration. Each model becomes a table, and fields become columns. Relations are defined with annotations. Here's a typical schema with user and post models. Note the use of UUIDs and the relation between them. Prisma Migrate generates SQL files from schema changes. In development, use Migrate Dev. In production, always use Migrate Deploy. Use these commands to manage migrations. The create-only flag lets you add custom SQL. Prisma Client provides a fluent API for CRUD. Always use select to limit fields and include to fetch relations in one query. This shows creating a user with a nested post and fetching published posts with selected fields. Prisma supports complex filtering, cursor-based pagination, and aggregation. Use cursor-based pagination for production APIs to avoid data drift. Here are examples of cursor pagination, relation filtering, and aggregation. Prisma allows nested writes to create or update related data atomically, but cascading deletes can cause data loss. Test them first. These examples show creating a user with posts and updating a post along with its author. Prisma supports interactive and batch transactions. Always catch Prisma-specific errors like unique constraint violations. This shows an interactive transaction for fund transfers and error handling for unique constraint violations. Tune your connection pool size based on expected concurrency. Enable query logging to identify slow queries. Configure logging and set connection limit in your data source URL. For integration tests, use a separate database and reset data between tests. SQLite works well for simple CRUD tests. This test setup runs migrations before tests and cleans up data after each test. In production, generate Prisma Client during the build step. Use a connection pooler for serverless environments. This Docker file generates Prisma Client during the build stage to avoid runtime generation. Common mistakes include n+1 queries, connection leaks, and unparameterized raw queries. Always use select and disconnect on shutdown. Always disconnect the Prisma client on process signals to avoid connection leaks. Prisma integrates well with GraphQL and REST. Always use DTOs to shape responses and avoid exposing internal fields. This shows a simple GraphQL resolver using Prisma Client. Prisma 7 introduces adapters that decouple the engine from drivers. You can switch databases by changing one line in the schema. The provider field selects the adapter. Switching to SQLite is just changing the provider. Connection pool exhaustion is common. Set connection limit to match your concurrency and monitor usage. Add connection limit to your database URL to control pool size. Prisma uses prepared statements, which can fill PG stat statements. Keep query shapes consistent to limit entries. Use these SQL commands to monitor and reset prepared statement statistics. Use Migrate Dev for development and Migrate Deploy for production. They behave differently. Dev can reset your database. In development with hot reload, cache the Prisma client on global this to avoid connection leaks. This pattern ensures only one Prisma client instance exists during hot reload. This is the same issue we highlighted at the start. Here's exactly why that happened. Prisma's migration generated an alter table that added a not null column with a default. In PostgreSQL, this rewrites the entire table, locking it exclusively. On a 500 GB table, that took 45 minutes. Prisma's auto-generated migration added a not null column with a default value, causing PostgreSQL to rewrite the entire 500 GB orders table under an access-exclusive lock, blocking all reads and writes. The fix was to break the migration into steps. Add the column as nullable, backfill data in batches, then add the not null constraint. This avoids the table rewrite and lock. This single line caused a production outage. In PostgreSQL, adding a not null column with a default rewrites the entire table, locking it exclusively. Without select, Prisma returns all fields, potentially leaking sensitive data. Always whitelist fields. Failing to disconnect on process exit leaves dangling connections, eventually exhausting the pool. Prisma 7 introduces a modular adapter architecture. Instead of new Prisma client, you must pass an adapter instance. For PostgreSQL, use @prisma/adapterpg and instantiate with new Prisma client, adapter, new Prisma adapter, pool. This decouples the query engine from the driver, enabling smaller bundles and faster cold starts. Prisma generates a new prepared statement for every unique query shape. Dynamic where clauses with different filter combinations can fill PG stat statements, evicting older entries and blinding monitoring. Normalize filter construction to share query shapes. Always include the same clause keys and condition on undefined values. Adding a not null column with a default in PostgreSQL rewrites the entire table, causing downtime. Use a safer pattern. Add the column as nullable, backfill in batches, then set not null. This avoids long locks. Enable logging and metrics to diagnose issues. Monitor pool usage and check for drift before deployments. Let's run through some common interview questions. What is Prisma, and how does it differ from traditional ORMs? Prisma is a schema-driven ORM that generates a type-safe client, eliminating impedance mismatch. Explain the difference between Prisma Migrate Dev and Prisma Migrate Deploy. Dev auto-applies and can reset. Deploy applies pending migrations without resetting. How do you handle N+1 queries in Prisma? Use include or select to fetch related data in a single query. And a few frequently asked questions. How do I switch databases in Prisma? Change the provider in Schema, Prisma, and regenerate the client. What is the best way to handle migrations in production? Use Prisma Migrate Deploy and test on staging first. How can I prevent connection pool exhaustion? Set connection limit and use a pooler like PG Bouncer. Let's recap the key takeaways. Schema-first approach ensures type safety. Use select to limit fields and avoid data leaks. Never assume migrations are safe at test on staging. Cache Prisma client in development to avoid leaks. Ready to go deeper? Up next, file upload in Node.js with Multer, then Node.js security, then logging in Node.js with Winston and Pinot, and worker threads in Node.js. Find them all at TheCodeForge.io. Thanks for watching. The full article and code examples are covered in detail at TheCodeForge.io.